Hello students, welcome to Learner's Planet, our theory session 1 of periodic classification of elements. So this is the last topic of your syllabus of 10th. Now in this students we will be studying about the different attempts made by different chemists to classify elements. Actually what happened that initially there were very few elements and there was no need to tabularize them or classify them. But as new elements were discovered, the number of elements increased. So there was a necessity to classify them to study their properties. So now let's start our discussion of periodic classification of elements. Now we'll start, I'll give you a small introduction on this. This is the actual or ideal arrangement together of those which are alike and separation of those which are unlike became essential after the discovery of large number of elements. So as I told you, after the discovery of large number of elements, their segregation, that is the elements having similar properties and elements having dissimilar properties, became essential. Now, one of the most outstanding contributions of the chemists of 19th century to the development of chemistry was to classify the chemical families and arrange them in the form of periodic table. Actually what happens, there were elements which were found, they were segregated. Every time when you need to study an element, you have to take out a book or you have to write its properties separately. But once these elements are grouped into the periods or groups, what happens? The study of the elements becomes easier. Now let's see who made the first attempt to classify the elements. Dobereiner was one chemist who tried to group the elements. Dobereiner's law of triads. He was a German scientist. German scientist Dobereiner identified some groups of 3 elements having similarity in chemical and physical properties. So he identified a group of 3 elements which are similar in their chemical and the physical properties. He grouped the elements in triad or groups of 3 elements. So what he did, students, he grouped these elements as a 3-3, as a group of 3 or the triad. He observed that the atomic mass of the middle element of the triad is equal to the arithmetic mean of the atomic masses of the other 2 elements. Now to explain this, I'll take some examples. I will discuss some examples. Like this, say this was a triad, lithium, sodium and potassium. What he said was that the atomic mass of the middle element was the arithmetic mean of the first and the third element. So it becomes like 7 plus 39 divided by 2 will give you what? 23. Now this 23 is the atomic mass of the middle element. Likewise, there was chlorine, bromine and iodine. So the atomic mass of chlorine is 35.5 and iodine is 127. Now the average of this, that is the sum of the two divided by 2, will give what? 81.25. That is approximately equal to, that is much more than 80, but he took it like that. Now there was S32, Fe79 and Te127. So the average of the atomic masses of 2, that is sulfur and tellurium, gives what? 79.5 or the 79. That is the atomic mass of selenium. The next one is calcium 40, strontium 88 and barium 137. So the atomic mass of calcium comes out to be 137 divided by 2. What we are getting is 88.5. But the students, this was applicable to only few elements. This was not applicable to all the elements. Now let's see its drawbacks. What are the drawbacks of this? The limitations of Dobereiner's classification. Dobereiner could identify only few triads from the elements known at that time. So there were only few triads which obeyed this thing, that the atomic mass of the middle element is the average of the masses of first and third elements. Law of triads was rejected as some triads have nearly the same atomic masses, like iron, cobalt, nickel. These have got what? These have similar atomic masses, like your ruthenium, rhenium and palladium. These have also the similar atomic masses, like your osmium, iridium, platinum. These have also the same atomic masses. So, his classification was, it was the first attempt by any chemist, so still we are reading this, but that was not up to the mark, or that was rejected. So there were several other attempts made by the chemists. Now let's see who made the second attempt. It was Newland. He gave Newland's law of octaves. Now what was this? According to Newland law of octaves, when elements are arranged in the order of increasing atomic masses, the properties of the eighth element starting from a given element are the repetition of the properties of the first element. How? What is it saying? When the elements are arranged in the increasing order of their masses. Say I'm taking your sodium, potassium, aluminium, after sodium we will get in the increasing order of their masses, okay? So after sodium we are getting magnesium. After that there is what? Aluminium. Then there is, what will be the thing? 13, and then 14 atomic number. 14 is the atomic number of silicon. Then is phosphorus. Then is sulfur. Then comes what? Argon. So what he is saying, that the atomic masses, right? So this is what sodium is, 22. This is, okay, let's take the atomic numbers here. What is he saying? That if these are arranged, this is in the order of their increasing atomic masses. Now, what is he saying? That the properties of the eighth element, that is this, the properties of the eighth element is what? Is the repetition of, now this is what? This is 1, 2, 3, 4, 5, 6, 7. Again here, potassium, right? Again here, rubidium. So what is it saying? That the properties of the eighth element, this is the eighth element, is the repetition of the first element. Likewise, this is again the eighth element. So its properties are the repetition of this. So this is Newland's law of octaves. Now let's see what are its features and what are the drawbacks of it. Say like this it is arranged. It is like the musical notes. Sa, re, ga, ma, pa, dha, ni, and again sa. Okay, So lithium atomic weight is 7, beryllium atomic weight 9, boron atomic weight 11, carbon atomic weight 12, nitrogen atomic weight 14, oxygen atomic weight 16, and fluorine atomic weight 19. Now when these are arranged in the increasing order of their atomic masses, what is happening? The properties of the last element is the repetition of the properties of the first element. So the property of the eighth element is the repetition of the property of the first element. Now what happened? What is he saying? That the properties, that is the physical and the chemical properties, depend on their atomic weights. And he tried to arrange all the elements according to their atomic weights. Now let's see the drawbacks of this. The limitations. The limitations of Newland's law of octaves. It was applicable to the classification of elements up to calcium only. After calcium, this was not at all applicable. After calcium, every eighth element did not possess the properties similar to that of the first element. So, what about the students? That the properties of the eighth element were not similar to the first element after calcium. Now let's take a few more drawbacks of this. The properties of the elements were not taken into account, and elements were arranged in the order of their increasing atomic masses. Now while arranging, we saw that how the elements are arranged there. Say we had taken what? The elements arranged were lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. Now these were the arrangements of the elements. Now how they are arranged? They are arranged according to their increasing atomic masses. So this is increasing. Atomic masses. What about their properties? Did he say that the properties, they are arranged according to their properties? No. He simply arranged them according to their increasing atomic masses and told that the property of the eighth element is similar to the first element. That's it. Now in this case, no vacant places were left for the elements which were discovered later, and so many elements occupied wrong positions. Now students, at that time there were some 50 or 55 elements, right? Now what he did was he arranged them according to their increasing atomic masses. But did he left any space for the new elements? Did he left any space for noble gases or for lanthanides or for actinides? What he did, whatever the available elements were, he arranged them in the order of their increasing atomic mass and took out a conclusion that the property of the eighth element or the properties repeat after every eighth element, right? That is, the property of the eighth element is similar to that of the first element. He didn't take into account anything, or neither he left any vacant space. So his law was also discarded. Now in this, after the discovery of the noble gases, the idea of octaves did not work. Now after the discovery of the noble gases, there are no noble gas here. So that idea was discarded. Okay. Now let's see who all made the attempts to classify elements. Now here is the Mendeleev classification. What is Mendeleev's periodic law, or on what basis his classification is based, on what fact his classification is based? So Mendeleev's periodic law, what is it? The physical and chemical properties of the elements are the periodic functions of their atomic masses. What does it mean? That the physical and the chemical properties of elements depend on physical and chemical properties depends on the atomic masses of the elements. So the physical and the chemical properties of the elements depends on their atomic masses. And what he said was, if the elements are arranged in the order of their increasing atomic masses, what happens? Then the properties of the elements are repeated after regular intervals or periods. So what is happening? If they are arranged in the increasing order of their masses, then the properties of the elements are repeated. Let's see how he arranged. I'll tell you in details about the Mendeleev's periodic table, but here I'll illustrate this. Say if there is hydrogen, lithium, sodium, potassium, rubidium and cesium, right? How are they arranged? They are arranged according to their increasing atomic masses. So what he did was, he classified all the elements on the basis of their increasing atomic masses. Likewise, your beryllium, magnesium, calcium, strontium, barium and radium. So this was Mendeleev's classification, and he made the first attempt to classify and tabularize the elements. Now the only drawback, this was like Mendeleev was the first to arrange elements in tabular forms. But what he suggested that the properties depend on the atomic weights. Now there are certain chemical properties like the valencies. If I take the simplest one, valency, what is it? It is, in simple terms, we can say combining capacity of an element. So what is a valency? It is a combining capacity of an element. Now on what it depends? It depends on the number of electrons present in the valence shell or the outermost shell of an atom of element. Say, if I talk of sodium, what would be its valency? It would be 1. What would be the valency of magnesium? It would be 2. What would be the valency of aluminium? So it is 2. Aluminium would be 3. Likewise, oxygen, the valency is 2 again. So, is this periodic table explaining about the valencies of elements or the combining capacity of elements? No. It is just arranging the elements on the basis of their atomic weights, that is the sum of, what is atomic weight? Atomic weight. I'll first tell you this. What is atomic weight? It is the mass of an element, right? Or it is the average mass of an atom of element. So here we can say atomic weight is also the sum of number of protons and neutrons. That is, it is given by A and it is P plus N. Is it taking into consideration the number of electrons which are actually responsible for the formation of bonds? No. It is atomic number which gives you the number of protons, and in an atom the number of protons is equal to the number of electrons. So here most of the chemical properties he couldn't explain. Most of the chemical properties of the elements he couldn't explain. But the most basic thing or most important thing which he did was that his was the first attempt to tabularize the elements. Okay? Now moving back to our sheet. So Mendeleev's periodic table is based on the atomic masses of the elements. Now this Mendeleev's periodic table consists of groups and the periods. The vertical columns are called the groups and the horizontal rows are called the periods, and he arranged the elements in them. Now in my next session, students, I will be discussing in details about the Mendeleev's periodic table, about the advantages as well as the anomalies of Mendeleev's periodic table. So you just go through this. So thank you very much for listening patiently. We'll be meeting in our next session and we will discuss about the Mendeleev's periodic table.